Super Science Smorgasbord Lesson 4, all about magnets, and this is the floating paperclip take-home activity. Our activity learning objectives, what we hope the students to learn and gain by the end of the lesson, are that students will be able to observe and explain that a metal paperclip is attracted to a permanent magnet even though it is not magnetic itself, and observe and explain that the magnetic field around a magnet can apply a force to the paperclip without touching and cause the paperclip to float in the air. Hi, I'm Josh Morris with Science Matters, and this is Super Science Smorgasbord Lesson 4, all about magnets. All magnets have two poles, a north pole and a south pole. We could call them a positive pole and a negative pole. And just like in the world around us, opposites attract, like charges repel. So the north and the north would repel, but a north and a south pole would attract each other. Can we make some things that usually aren't a magnet into a magnet themselves? And the answer is yes. If we take some metals, we can actually force them to become a temporary magnet just using a permanent magnet like this little ceramic magnet here that can force the electrons in the metal to all point in the same direction. And that's really what makes a magnet a magnet. The more electrons we can get to point in the same direction, the more magnetic something's going to become. The other really cool thing about magnets is they have an area all around them called a field that can apply a force to other objects without actually touching those objects. And that doesn't happen very often in science. Usually we have to be in contact with something else in order for a force to happen. But magnets can actually apply a force at a distance because of their magnetic field. And that'll become very important as we get to our magic tricks, or at least things that look like they're magic, even though they're really just science, here in a few minutes. So one of our first take-home activities, which is part of the bag of magic tricks the student will make by the time they're finished today, is called the floating paperclip. So for this activity, for each student you're going to need some masking tape, a ceramic magnet, which they'll need some scissors, one paperclip per student, and a roll of kite string. And you're going to cut that kite string to about 12 to 15 inches long. So when we're finished, what it looks like is this right here. I'm actually going to take the masking tape and tape the string to the table. And now here comes the fun part. Some metals, like the metal that make up this paperclip, can be forced to become a magnet. They can become a temporary magnet if they become attracted to the magnet inside of its magnetic field. So here we go. We see that the magnet attracts the metal paperclip and it can lift it up into the air. We can even pull it until the string gets so tight that we're trying to lift it off the ground. Now here comes the cool part that the kids are going to think looks like magic. If I pop the magnet off just a little bit, the magnet's magnetic field can actually keep that paperclip in the air. And as you just saw, if I go too far away, the field becomes weak enough that gravity wins and the paperclip falls back down to the ground. Now the fun part about this is students can try it over and over and over again until they master the art and science of this cool looking magic trick that allows us to make the paperclip dance and move like it's floating through the air without touching it with the magnet, all because the force being applied by the magnet's magnetic field to the paperclip. And again, if I get too far away, it falls to the ground, but all I have to do is pick it right back up, and once again, we'll pop the magnet off. And now we can make our magnet dance and float anywhere we want to, all because of this magnet's magnetic field. This is Super Science Smorgasbord Lesson 4, all about magnets, and this is the envelope tricks take-home activity and the cup and ball trick take-home activity. And our activity learning objectives are that students will be able to observe that a magic trick and illusions can be created using the properties of a magnet and its magnetic field. So our next activity is another trick that goes into our bag of magic tricks using magnets. This is called the envelope trick, and there's two different tricks. You can do both or choose one or the other. It kind of depends on the skill level of your students. So for this activity, you're going to need, per student, 4 paper clips that either you or they can hook together in a chain, 4 individual paper clips not hooked together. Again, the students will already have their ceramic magnet that they've been using in class. You'll need some double-sided tape, and then 1 business-size envelope per student. And what you're going to do is take the double-sided tape and tear off a piece that's just long enough to place down the middle of the envelope inside, so that by the time you're finished, you've created an envelope with 2 pockets. And that's important for either one of our tricks. And so I went ahead and did that in this envelope right here. And the other thing I did is I took my magnet and I put it down into the left-hand pocket. Now, the first trick that the students can do involves the individual unhooked together paper clips. And the important part about this one is finding where your magnet is in the envelope. Mine happens to be right here. And now what we're going to do is we're going to get these paper clips to hook together without being a chain and float above the envelope. And so what I do is I hold right above the magnet. I slowly slide, and if I do that, that's messed up my trick because now the magnet's won out, so I don't want that to happen. What I do is I slowly slide my second magnet into place, and just like that, I can make it float in midair without actually hooking them together. Now, if I get really good, I can lift it up just a little bit more. I can grab another individual magnet, and again, if I get too close to the magnet, they fall back onto the envelope. And so that's what the kids are going to have to practice, is finding out where is that spot that I can be far enough away and still use the magnet's magnetic field to make two paper clips hook together without actually being hooked, and then slowly slide a third paper clip into place. And again, good old magnet wins out. So this one's going to take some practice. This is one that I even haven't mastered yet. And again, depending on the manual dexterity of your students and how old they are, they might struggle with this one a little bit. So let's come back to that one in a minute. Let me show you the other one that everybody can definitely do. So in order to do this, we're going to leave the magnet in one pouch of our envelope. Before I do the trick though, and when nobody's watching, I'm going to take the 4 paper clips that are hooked together, and I'm going to put them down into the other pouch of the envelope. And now here comes my magic trick. So here are my 4 paper clips that aren't hooked together. I'm going to have somebody investigate and look at them to make sure they aren't hooked. I'm going to take them and put them into my envelope, say my magic words, hocus pocus abracadabra, turn the envelope over, shake them out, and sure enough, the 4 paper clips have just hooked themselves together. Now, might look like magic. Remember, science is never magic, but a lot of times magic is science. And all we really did is the pouch that had the magnet is where I dropped my 4 individual paper clips. They were attracted to the magnet. I held them in place. So when I turned the envelope over, the 4 hooked together magnets that were in the other pouch fell out, and it looks like a lot of magic and a lot of fun. So here's one of our other magic tricks that goes along with magnets and being attracted to magnets and the good old magnetic field. Our final magic trick is called the cup and ball trick. And again, per student, you will need 1 cup. Again, they'll have their ceramic magnet they've already been using. They'll need 1 paper clip. They'll also need 1 little piece of paper. Any scratch paper works. If you'll just take the cup and use a pencil to trace it on that paper to make a bottom, I'll show you why in just a second. You'll also need, again, the paper clip and then 2 pieces of aluminum foil. Along the way, while we're building this trick, the students will also then need some regular tape, some regular Scotch tape, as well as some double-sided tape. So the way this works is we're going to take our cup and we're going to put the magnet on the bottom of the cup using the double-sided tape. So I'll take my double-sided tape, stick a piece right on the bottom of the cup, stick my magnet to it, and now when I do this trick, my hands are big enough that I can cover up the magnet and people won't see that it's there, and that's kind of important. Some of our students' hands are pretty small, and that's why we decided to create this kind of false bottom. So if I just set this over the top and take just 1 or 2 little pieces of regular Scotch tape and tape this in place, now people can't see that there's a magnet on the bottom, even if the hand isn't big enough to cover the bottom of the cup. The other thing that I'm going to need to do is make 2 aluminum foil balls. One I'm just going to crumple up, leave it off to the side. I want to make the second one look a lot like the first one, but I'm also going to put a paper clip down inside of it. And if you don't know, aluminum itself is one of the metals that is not attracted to a magnet. It can't become a temporary magnet. So that's why I put the paper clip down in my second ball, is because I'm going to make it magnetic when we start to do the trick. So now I have my 2 balls, my cup with the false bottom covering up my magnet, and now I'm actually ready to do the trick. So here I have a cup, and here I have an aluminum foil ball. If you look into the cup, there's nothing down inside of it. So I'm going to take my ball, place it down inside of there, and you can see that I can easily pour the ball out of the cup. So once again, we'll put the ball back into the cup, and this time I'm going to flip the cup over on the table, swirl it around, and nothing actually happens. And that's totally okay. So now I'm going to take this, and I'm going to put this into my pocket. And you're going to watch me put it right down into my right-hand pocket. Now, nothing on the table. I'm going to take the cup, I'm going to swirl it around, and wait a minute, didn't I just put that in my pocket? You guys saw me put that in my pocket. Let's try that again. All right, so I take it, I put it in the cup, I swirl the cup around, and nothing happens. Because where did the ball go? The ball ended up in my pocket. Now, this is a trick that the students are going to have to work on just a little bit. This is why we have 2 aluminum foil balls, one with a paper clip, one without. And the way I start this is I'm holding the ball with the paper clip in my right hand. I take the one without anything in it and I can put it in the cup, and even though there's a magnet on the bottom of the cup, the foil's not attracted to the magnet. So everybody sees there's nothing in the cup except for the ball I put in there. I flip it over, I spin it around, and sure enough, there's the ball. Now when nobody's looking, I take the one that I've palmed, I drop it down into the cup, and because it has a paper clip, it's now attracted to the magnet on the bottom of the cup. It won't fall out. So now, people don't see that it's inside of here. I can take the first ball, put it in my pocket. When I take the cup and put it on the table, though, I'm going to hit it with just a little bit of force so that I dislodge the ball that was attracted to the magnet because of the paper clip. So then I can spin it around. Everybody thinks the ball's in my pocket, but really, the ball shows up right here. So now they're amazed. I take the ball, I put it back in the cup. Again, it's attracted to the magnet, so this time I don't slam it on the table. I set it down gently and spin it around so that when I open it up, the ball's gone. And where did the ball go? It was in my pocket. It was the one I had put in there originally, and all because this second foil ball has a paper clip inside of it that's attracted to the magnet. I can do this fun little trick that makes the ball appear, disappear, and reappear again, all because of magnet.